No need. So Department of Mechanical Engineering, IIT Madras, is one of IIT Madras's original, oldest and largest departments spread across the campus. Lots of buildings. When I was a student here, we had to keep walking between buildings because the labs are somewhere else. It's spread across the campus. A large faculty base. I'll give you the faculty count and the student count soon. Yeah. Should I play this video? Let's come back to the video later. Cool. I'll play the video if we have time later. So department at glance, 70 faculty, 48 in QS. First of all, you'll hear this from everyone that we don't believe too much in QS rankings, but since we are asked again and again, we show it. Yeah. Broadly, mechanical engineering is broken into 3 fields, broad fields. Are any of you, the parents, are any of you mechanical engineers? Okay. Okay, great. So mechanical engineering is a broad field. There are lots of subfields. When you join mechanical engineering at any institute, whether it's IIT Madras or anywhere else, you would take courses, take foundational courses in every kind of field, and then in your 3rd year, 4th year, you would start specializing. You would take electives, and you would decide where you want to focus. For example, when I was in 4th year, I wanted to do more of automotive engineering, automotive focused stuff. So I took electives in vibration, in vehicle design, and so on. But that was in my 3rd year, 4th year. So broadly, three buckets: manufacturing, advanced manufacturing, production, additive manufacturing. Do you know what is additive manufacturing? In general, manufacturing is subtractive, which means we take a block of something and then we cut things from it. We machine things away from it. So we take like sculpting, right? You take a big block of wood and then you cut out, and what is left is what you want. Additive manufacturing is where you add things, colloquially called 3D printing, but the industry term is additive manufacturing. Today, there are additive manufacturing in everything: plastics, metal. We have a startup here who is 3D printing or doing additive manufacturing for rocket engines. So that's where we have reached. Additive manufacturing, precision manufacturing, smart manufacturing. When you think of manufacturing, you may think of everyday objects like toothpaste, soap, shampoo, or maybe even like plastic parts. But there are things which require a lot more precision, lot less tolerance for errors, airline parts, space parts, and so on. So their manufacturing systems are more complex. Process engineering, when you decide you want to manufacture something in a particular way, making it one time, making it 10 times, and making it 1,000 times, million times, the processes change, the systems change, the amount of engineering required changes, so that a lot of process engineering. So that's the first bucket, manufacturing. I was in manufacturing, spent my first few months in factory. So a lot of mechanical engineering jobs end up in manufacturing and making things actually happen, getting them in our hands. Even something as simple as, I mean, not as simple as, but even something as ubiquitous as a phone has gone through a large amount of manufacturing in various places, in various factories. Then there is design, mechanics, robotics, dynamic controls, design optimization, intelligent systems, automotive systems, smart structures. So design, especially in the first 1 or 2 years, the design courses are very exciting. I remember my first few courses, we learned things like CAMS. I don't know if you know what a CAMS is, but it's like imposing physics on real world things. It's exciting to learn in the first few years. And then eventually you learn how to move ahead. Instead of thinking of rotating arms, you think of robotic systems, mechatronic systems, dynamic systems, and so on. So the second block of mechanical is design, and the third block is thermal systems, CFD is computational fluid dynamics. Turbulence, heat transfer, combustion, and you may feel these are old topics, but they keep revisiting. New things happen, and these topics become exciting again. Combustion, for example, is a really old topic, but if you are solving for combustion of a rocket engine, if you're solving for, you know, combustion in specialized conditions, again, it becomes a new topic. So, yeah, a lot of thermal work and CFD work that is done is computational, but a lot of it is experimental. Some of the systems, some of the real world systems like environment systems or water flow in a river or things like that, we don't understand it fully from a physical point of view, so we have to experiment it. We have to run similar experiments to real, and then figure out, okay, this is how it works in a lab setup, how will it work in a real setup? So a lot of experimental research happens. Energy systems, propulsion. One of my closest friends in mechanical engineering, he was into batteries in 2006. I have no idea why. I think his father was a chemist. So he was really excited about batteries, and we were like, what are you doing? Like, what is this? But today he's one of the world's leading battery scientists, and as you all know, batteries have become a very hot topic across the world. So mechanical engineers tend to diversify a lot because it's a broad field with lots of subfields. Yeah, it's kind of hard because everything gets thrown at you. And then in your second year, third year, you are like, oh, this is how this works, this is how this works. The great thing about mechanical engineering is that you get a little bit of overview into almost everything around you. So from how does power get generated, to how does power get transmitted, to what are the various things that that are there in this room, how does lights work, how do fans work, all of that. Everything mechanical engineering has some hand in it. Some course will cover it in some way, and then later on you specialize. You decide whether you want to spend more time with engines or heat transfer or so on and so forth. So from engines to robots, from factories to satellites, turning ideas that work, getting them to move and getting them to scale. Yeah, some more detail here. Yeah, tell me. Okay. So in all, mechanical engineers tend to work in all kinds of industries: aerospace, defense, automotive, mobility, energy, robotics, automation, biomedical. I have friends in each of these doing different things. Some of them are very interesting also. I think friends of mine who are in EVs or, I mean, they are just having the time of their life right now. In my first year, I think I was told that initially there was defense engineering and civil engineering. Civil being non-military. So there was military engineering, and then there was civil engineering. And then from civil engineering, after the Industrial Revolution, came mechanical engineering. So you can think of, and then electricity got invented, so there was electrical engineering. So you can think of civil, mechanical, and electrical engineering as the three sort of mother branches. If you want to be a generalist in the true sense, if you want to decide later what you want to specialize in, then these three courses are the broadest. Yeah, I think this was a very exciting moment for all of us. I don't know if you've seen Falcon 9's chopstick maneuver, or in fact, even before this, when I don't know how old you would have been when SpaceX rocket landed back, returned and landed back on its on the landing pad. Did any of you see that? Like maybe about. Yeah, so that was a very exciting moment for mechanical engineers. I mean, engineers in general, because it's one of those problems which are very hard to solve. It requires a lot of control engineering, a lot of combustion, You need to exactly balance everything. A lot of sensors and actuators have to work at the same time. They have to work very fast. They have to communicate very fast. They have to decide what to do very fast. It's the kind of things that mechanical engineers get very excited about. Another thing that I would say that as a mechanical engineer, you realize that life is very interdisciplinary. From a JE class 12 point of view, it might feel like you're choosing one branch of engineering, but real world problems are not like that. Real world problems are knotted. You need to know a lot across disciplines to be able to solve real world problems. If you meet real engineering teams, they have different kind of engineers working on the same problem. So that's another thing that I have felt as even when I started my career, is that I'm expected or I'm trained to know a little bit of everything so that I can run this factory, or so that I can make sure that production is happening and so on. We were, and also in general, as an IIT engineer, you are expected to be a good engineer. So you're given a lot of responsibility. So when I graduated, I was, my first job as a factory engineer was quite high, like manage this factory, that types. So then the expectation is also that you've learned a little bit of everything and you're able to apply it. There are professors who would end up, if I just go back here, there are professors who would end up focusing on some areas, some applications. There are also professors who would be focusing on some technologies. So maybe the professor works in heat transfer and he's looking at applications of heat transfer across industries. Or maybe there are professors who are looking at solar energy transition, and then they are looking at different aspects of solar energy transition. So they've gone deep into one field, but there'll be other professors who will be working across, solving different kind of problems. I was talking to a professor once, and he was telling me that his main area of focus is how fluids move, but the equations he solves and the way he thinks of it can be used across. So at one point of time, he was doing a project on when you take an inhaler puff, that puff that goes in, how does it spread inside your lung, right? Is very similar to how fluid moves. And then he was telling me that in large crowds, like where 1 million people turn up, and they have to be guided. And he was saying that human movement is also very similar. So he was contracted by the government in some of these large crowded situations to sort of set up cameras and set up movement systems so that, so what I'm trying to say is that some professors think like that I understand this concept, I will apply it across. And some industries think I want to affect this industry, I will go deep into this industry. So both happens. Yeah, so a lot of the challenges that we are facing, I know that we only talk of will AI affect our jobs? And the newspapers are full of only AI, but there are a lot of challenges from an engineering point of view that are very, very exciting for engineers, and a lot of money is flowing into them. Top being energy transition. And you know, from outside it might feel like, oh, it's so simple, we'll just put a lot of solar cells. But the only engineers know what kind of problems that creates. So for example, I'm currently now working with some companies which we are working into battery transition. In India, what's happened is that we have installed too many solar cells. So what happens is that in the daytime, there is too much energy in the grid. And at the night time, there is too little energy in the grid. So in day, because there's so many solar cells that are active, the energy gets pushed back into the grid, and that's causing problem at a grid level. And at night, there's not enough energy everywhere. So it's a huge problem, energy transition. You already know that our country is now moving to a smart meter transition. Some of you might have already got a smart meter at your house. 250 million smart meters are going to be put in our country. And after that comes in, it's possible that electricity grid distribution may be controlled by algorithms. So challenging, exciting problems that are there for mechanical, electrical engineers to solve. Um, Another problem that you might have heard of from the newspaper is that uh, coal gasification is a technology that India can excel in. We have a lot of coal, we have very little gas, but it's hard to do. It's an engineering problem. It's not a science problem. We know, as a technology, we know what to do. We just not sure whether we can do it in large scale and whether we can do it in less amount of money. So problems like that. Space economy is a big challenge. We want to be a space-faring nation, so that requires a lot of engineering work. We are expecting robots to enter the workforce in a big way. Aerial robots, land robots, robots that are doing pick and place is a little bit more solved problems. Robots that can fly and deliver. I was just telling someone that in Bangalore, there are already companies that are experimenting, routinely transporting from one depot to another depot by air, by drones. So, it may be that in the next 10, 20 years, drone-based delivery could be quite common. So again, that feels like it's solving some problems, but it'll cause more problems. So there will be a lot of engineering work that will come up. Climate adoption, a lot of climate disruptions happened. We get affected by any kind of climate disruption across the world, so we need to be more climate resilient. A lot of engineering work has to happen. Yeah, precision medicine. So there are lots of open challenges. I'm sure the AI folks and the CS folks think that the next 20 years are going to be only about them. Not true at all. Their systems can't work unless the underlying mechanical systems are working. Yeah. What courses are offered? So broadly, the course curriculum is like this. First year, you do foundational courses, foundational labs, foundational workshop. How are things made? What are the machining processes? What are the broad equations? One of the most exciting courses in first year is thermodynamics, where I think you must have learned a little bit about Carnot cycle already, but you learn a lot more about it, how to apply it, where it's valid, where it's not valid, internal combustion engine, external combustion engine, all of that. A lot of mechanics. Yeah. And then your specialization courses, fluid mechanics, strength of materials, kinematics, manufacturing technology, all of that start. Yeah. And then you can decide as the course, maybe I'll open the course curriculum also. I'll show you how the elective system works. Then you can decide I want more heat transfer, or I want more machine design, I want more fluid dynamics, and so on. And then accordingly you can specialize. When children choose to specialize, they choose between what am I interested in, plus what am I good at, plus where is the faculty really strong, plus where will I get good research opportunities. So it's a mix of things, mix of interest and opportunity. There is opportunity across, but like my friends who chose to go into solar in 2009 and 10, they're doing really well now because the country went through a solar boom. And I had also told you my friend who chose to be in batteries in 2008 now is one of the world's leading scientists in batteries. So people take these choices slowly. You don't have to take that choice today. You can understand the full breadth of mechanical and then choose. Mechanical engineering, chemical engineering, these are also branches which teach you a lot about figuring things out on the go. Engineering systems in real are not perfect. So they teach you how to deal with imperfect systems. And that experience generally helps across industries. So a lot of mechanical engineering students end up being managers, factory managers, process managers, maybe consultants, and so on. So not everybody becomes a hardcore engineer. Some people become adjacent to engineers. Okay. Yeah, I think this, we spoke about it in the morning, right? Like all branches can take minors and all branches can take IEEEs. Yeah. So, what are the research focus areas in our department? Sustainable systems, hydrogen technology. Some faculty are working in. I was listening to some of them talk about how hydrogen as a fuel source for certain applications is growing. We may not put hydrogen in our cars, but we may put it in our trucks and other things, or as a static place. I mean, static installation, not mobile. Solar energy, a lot of work is happening. Carbon capture, sequestration, a lot of work is happening. Desalination, of course, you probably know if you're from Chennai that Chennai gets water from one of India's largest desalination plants. So it's a very active problem for Chennai. Thermal and fluid systems, again, a lot of work happens. Because it's a experiment-driven, computationally heavy work, some of the thermal fluid dynamics work is also basically requires a lot of ML and AI and a lot of coding. Yeah, some next-gen computing work, modern mobility, smart manufacturing, bioengineering, micro nano systems. I think maybe I'll pass on this presentation so that I'll stop early and take questions. We have labs in everything. As I was saying, as a student, you have to keep going from lab to lab. There are more than like 12, 13, 50. I don't know exactly how many labs are there now, but when I was there were 12 labs. Students of mechanical engineering tend to be more involved in student activities. They're generally easier to sort of work with in things that require multidisciplinary work. So how many of you have already done your CFI tour? Oh, great, fantastic. So some of you will still do it. So you can see that maybe about 30-40% of students involved in CFI will be mechanical engineers, simply because it's easier for them. They can understand the various things that are going on. Yeah, so this is part of commentary. Yeah, these are some of the products that have been patented from one of the labs in IIT Madras. This is actually a very high visibility lab. Maybe you have already seen their work. If you have seen these Zomato drivers on an electric wheelchair, have you seen that? Like when you're just in wherever you stay, have you seen Zomato drivers on a wheelchair? Yeah, so that exact wheelchair is developed by a company called NeoMotion. It's an IIT Madras startup. Their work came from a lab called R2D2. They do work in assistive technologies that can assist. So these are some of their projects. NeoFly, NeoBolt, those are electric wheelchairs. Prosthetic knees, standing wheelchairs. Standing wheelchairs are used in hospitals for recovery. Patients who have need help in relearning how to stand and walk. Yeah, so mechanical engineers end up everywhere as engineers, plus as consultants in startups and so on. Career pathways. When I was a student, maybe about 20% to 30%, yeah, maybe 30% of my branch was 120 students, so about 35 kids would have gone abroad for higher studies. Some of them are professors today, some of them have come back. Today, India has a lot of jobs, which maybe in my year were fewer. So the number of students applying abroad has come down. Also, the visa situation and the funding situation abroad has changed. It was much easier 20 years back, now it's harder. So students take a decision in their third year whether they are in a position to go abroad and study, whether that will be good for their career, or whether they can get a job here and that will be good for their career. So, yeah. Yeah, so this is what I was saying. So core engineering, a lot of companies come to campus. Top companies, I'll just show you this slide. These are some of the companies that come. We have said this again and again. Most of these companies are open to hire from all branches. But depending on the job profile, may be easier for some companies to hire than others. Typically, about 400 companies come in a particular year. So they're all the top companies in their field. Off campus, I joined Unilever, so that was my first job. My first factory job was in a Unilever factory. My internship was also, we made Surf Excel, and then when I joined as an employee, we were making Vim. I can tell you a lot about Vim Liquid. Yeah, someday. So out of this list, Aether is a campus startup, and Grow has IITM alumni as founders. And maybe 10 years later, when we show this list, we'll have a lot of IITM startups here. But this is where we are today. A lot of people join consulting, finance, non-core jobs. Yeah. I think I should copy this slide to my presentation later, because we will talk about placement. Increasingly, a lot of students are choosing to start up. And we support it as much as possible. There are some additional slides I have, which I will show at 4:30. These are some of the startups that have come up in the recent past. The flavor of startups that come up from IIT Madras is usually deep tech. So I'll just tell you a little bit about what these startups do, so you will have a flavor of it. Detect makes systems for industries to be safer. So they make vision systems that can take feed from a camera in a factory and say things like, these workers are not wearing helmets, or these structures seem to be swaying, this area the temperature is too high, and so on, which is helpful in accident prevention. You'll be shocked to believe that the amount of labor accidents across the world is still more than 100,000 fatalities a year. Is very, very high. And they sell to, they started here. Now they have moved to the US. So they sell to US companies, mostly companies like Shell, companies which have a lot of factory and operations, which are unsafe. They make them safer. NeoMotion makes assistive tech, I showed you already. Zyma makes sensors for high temperature use. So their sensors work at, they build temperature, velocity sensors, but they work at 1,000 degrees. So say you are a steel plant and you want to measure temperature, you cannot put a thermometer in because your thermometer will melt. So they make temperature sensors which work at that kind of thing. I don't know what AirOK does. Planis does underwater robots to inspect underwater rigs. So all these oil rigs that are offshore, all the ports that have structures that go into the sea, those structures corrode over time. So their robots go and check whether those structures are still safe or they need replacement. Solinas, have you heard of Solinas? Solinas does something amazingly cool. They build pipeline robots to check whether there are leaks. So their robots are being used by the government bodies across India to check where leakage is happening. So we have this situation, I mean, all of you, if you're staying in Bangalore, Chennai, you keep seeing that suddenly one pipeline has burst and there's water flowing. So these bodies use Solinas robots to go into the pipelines and check where the leak happened so that the digging can happen at one place instead of the corporation going and digging the whole 200 meters of road to see where the pipeline problem has happened. Their robots also make digital maps. In our country, people have put water pipelines and sewage pipelines, but don't have any idea of where they are. So if you go to the municipality and ask, can you show me where the pipelines are? They don't have those maps. So Solinas makes these robots, and these robots can go into the maps and make a digital version of it so that in future, it's helpful. Yeah, I think I don't want to go into every robot, but every startup, but you can see that there's a flavor of deep tech, B2B, we want to solve industry problems kind of approach. I'll forward this to you. You can see our alumnus. Yeah, so great. So broadly, any questions? I'll be very disappointed if you don't ask me anything. I'll open it. I'll open it. This one, right? I think you mean the first table, right? Okay, okay. Let's go to the first table. They have just not given the split here. That's all. No, no, no. This is department. It's actually. Have any of the parents studied in an IIT or an NIT or? Okay. So IITs are set up on their own. So each IIT is different, and each IIT decides its own programs, courses. Obviously, they learn a lot from each other and from the industry, but they don't report to UGC, for example, which other universities have to do. And similarly, inside IIT, each department gets a lot of freedom. And it just so happens here that the ME department has not given this breakup. That's all. Let me try and find out if I can find the breakup from their details. Yeah, so let me do this off and send you a note. Any other questions? Just looking at this, I have these memories flowing back. Yeah, there are free electives. It starts in the 5th semester. 1, 2, 3, 4. Yeah, here, professional elective. Professional elective. So, these are the. This is so here 1. So this is 9. 2, 3. So 9, 9, 4, 5, 6. So 9 into 6, 54. Oh, there are 3 more. This can be a UGRC. You know what's a UGRC already? What? Yeah. So earlier, when I was a student, we had to do one BTech project or a dual degree project, which was a block of credits. I think it was like, the credit system has changed. So I'm not saying how much it was earlier, but now what happens is that you can do that project as an option. Earlier it was mandatory. Now it was like either you take courses or you do a project. They have renamed it to UGRC, and you get a block of credits. So I don't know if you know anything more. Huh? How many credits does UGRC count?
9 credits. UGRC.
Is it? Okay. Fine. So that this is what this says, /project/project/project/project. So there are 3 here, and there were 6 earlier. So if I go back here, yeah, so this will become whatever, plus 54. I mean, minus 190 minus 54 plus 54. Yeah.
your own project, or if you're doing a project under, say, a professor, can that still be converted into a UGRC?
It's usually with a professor or with CFI.
And if the project outcome is not satisfactory, do you not get the credits for it, or?
I mean, by nature, most engineering projects are sort of exploratory, so I don't know what that means. It's not like a, sorry? You can answer this? Yes. You're a second year student? Okay.
So nice that you're interested in research. You see, the UGRC at IIT Madras, the way it works is that you'll usually be doing a project with a professor, and the exact project you work on depends on the mutual consensus between you and the professor. Of course, it should be in some domain that the professor can advise you on. Okay, so there will be 9 credits offered to UGRC. So 9 credits is like a medium-sized course. That's the equivalent credits. So there is no exact results that you can demonstrate in the research because, UGRC is a 1 semester of research. You cannot come up with very good results or demonstratables from that, outcomes, right? So just like any other course, you'll be having grades for UGRC. These grades are not just judged based on how much outcome you have brought up, but it depends on how well you have done the research work. Okay, so it depends on the quality of research and not solely on the outcome, because provided the 4-month span of a semester and being a BTech student undertaking research, you won't be expected to produce results. It solely depends on how much research thinking mindset you cultivate and how you demonstrate it in your work. And your professor will be grading you, the professor under whom you are doing the project work, and it will have the usual grades as you have in any other course. So it's a credited scheme. Thank you. Yes?
You can only convert one project into UGRC.
The curriculum says 3.
I'm not sure of the count. Actually, I don't remember of there being an upper cap, but there could be one. So like sir remembers, there are maximum 3 UGRPs allowed, but if I'm not wrong, it's actually 2. You're allowed to take two UGRPs. Yeah. So you can take one.
UGRP or UGRC?
We use an interchange.
Yeah, it's meant to give you a taste of research. But this is what students do over their time here in all branches, not just here, is that they use these opportunities to understand professors' work better, understand that field better. Later on, they can choose that field if maybe they can get a reco from the professor when they're applying abroad, things like that. Okay, other questions?
Non-core.
How much is core versus
I mean,
non-core?
mechanical in general, and that's another question I had. The impression was that it's, especially in IIT Madras, is extremely intense. Maybe because you're the oldest and there's just so much to do that you're not going to really get time to do a minor in CS or something like that, which means you typically rely on a lot of core jobs. Again, I just wanted to see if it's a myth, and
Okay.
also how much in general, core jobs
Okay.
kids
So
get.
I think you have asked like 5 questions in one question. So let me answer them one by one. Overall statistics is 30% core, 70% non-core. Maybe higher in some branches, lower in some branches. Also, many jobs are both core and non-core at the same time. So it's kind of confusing. Some kind of consulting jobs require you to know engineering. So are they core or non-core? So, but broadly 30, 70. The non-core jobs, sometimes in the banking, finance jobs pay a lot. So those are the top jobs in the student interest. So they get better. The core companies, they come, they say we have great jobs, but none of the IT students want to join because they're getting better paid banking jobs. So that's the reality of the system. That's fine. The second question you asked is, I have forgotten what you asked.
It's pretty intense because there's just so much to explore in mechanical.
There is a lot to explore, but the mandatory coursework is not that much. Nothing is as intense as JEE preparation. So, I mean, you can also answer, but my coursework was heavy in the first semester and second semester. After that, it was very light. In fact, my 5th year, 2 semesters, I had 1 course. That's it. So some of you who went to CFI, I was part of the team that set it up. I was part of the student team that set it up. So most of my 4th year and 5th year just went running to different departments and grant agencies and fighting with everyone, saying, no, we must do this, we must do that, like whatever. So it was exciting. But I had only 1 course. So it's not, but I can understand that other students who really want to do more research, they would end up spending a lot more time in the labs and with the professors. Is your experience here? Is the coursework very heavy? Yeah, it's correct. The coursework is 20% lighter than what I had. So reduced. I don't know why, but yeah. Not only is it reduced, they have more electives. So the total net credits has come down by 20%, and the total free electives have gone up by 20%. I'm really pissed off. What is this? I wish I was a student now. I had a lot more time. Okay, any more questions? Yeah, so there is a student internship body which gets internships for students. Companies come to campus. But students do a lot of internships these days. They do like 6, 7 internships in 4 years. So maybe the campus will help you once. The other student, it's not, most IIT students have a problem of plenty. There's too much to do, too many courses to take, too many options, too many startups to join. Anybody reads a lot of literature here? Somebody who reads a lot? Okay, so Sylvia Plath has this book called The Bell Jar, where she says, as I lay down under a fig tree and I saw all the figs in the tree, and I thought this fig is one version of my life and that fig is another version of my life. And so like that, you have too many versions of your life that you will have access to. And then, and Sylvia Plath goes on to say that as I laid down there, I couldn't decide and all the figs died and fell down. So that is the problem you will have. You'll have too many options, too many internships, too many companies, too many directions. We can wrap up now. Yeah, we can. If no questions, we'll wrap up. Okay, great. Quick vibe check. Did you guys have lunch? Okay, so all are fed. Did you, are the tours working fine? Did you get to go to Heritage Center? Anybody went to Heritage Center? Some of you went. Campus tour? Campus tour is done? Okay. Okay, hopeful. So there's one now. Okay, sure. Okay, thank you. I think so. For some courses.